In this video, we're going to look at how to find the equation of the tangent to a curve at a given point. So I know I said quite a bit there, and I'll make sure that you understand each and everything that we're about to try and find before we actually try and find it. So let's look at an example. And in our example, I'd like us to try to find the equation of the tangent to a curve and let's make our curve y equals 2x to the third minus 4x plus 1 when x is 3. Alright, great. So the first thing that I would want us to do is actually be able to see the curve. And the easiest way to see what this graph looks like, what this curve looks like, right here, is to put it in a graphing calculator. So if you put that in your graphing calculator, you'll see something that looks like this. It goes up, it goes back down, and then it shoots up really quickly. Alright, so that's basically what our curve looks like. It's not perfect, but it's a basic idea. Alright, so what am I asking for when I ask for the equation of the tangent to a curve? Well, the tangent is a line that touches the curve at exactly 1 point. So in this particular case, our 3 is around here, let's say. Let's pull it back a little bit so we can see what's happening. So the coordinate of that point would be 3 comma something. We don't know yet. So that point is where our x is 3 and it hits the curve. I want to draw a line, and my line is already very terrible, but I want to draw a line that would touch the curve in exactly 1 point. So that's pretty bad. But what I was trying to do is touch that curve in that 1 point and that 1 point only. So now that line is called our tangent line because it touches the curve in that 1 point and that 1 point only. So in order to figure out the equation of that line, well, it is a line, so we would do a lot of things that we know from coordinate geometry to find the equation of the line. In order to do that, we need slope, we need a point, we need some stuff. Right now, all we know about that line is that x is 3. So a good first step is to figure out what y is, because we do need a full coordinate point. So in order to figure out what y is, let's call this our step 1. We need to find y. Now to figure out what y is, we do have an equation for y in terms of x. It says that y is 2x cubed minus 4x plus 1. I'm just taking that straight from the question. Therefore, y is 2 times 3 cubed. We know that because, of course, x is 3 minus 4 times 3 plus 1. Alright, so now at this point, all we have to do is plug that into our calculator. And when we do, let's see what happens. We get, let's see here, we get that y is 43. So that's a pretty high point there. When x is 3, y is 43. So we know the coordinates. We can just put that down so we can remember what they are. And we can move on to figuring out what the slope is. So let's call that step 4. Now, in any curve, you can find the slope at any point by differentiating. You may remember that from a prior video. So when you find the derivative, when you differentiate, all the same thing, it's really finding the slope at any point in a curve. So I don't know why I wrote step 4, but I totally meant step 2. I'm not jumping ahead so fast, not to worry. Alright, so step 2, differentiate to find the slope. So when we differentiate our expression, we get that dy over dx, and remember that's just something to say the derivative. We're not actually dividing the y by x, we're just finding the derivative here, is 6x squared. And if you're wondering how we got that, remember to figure out the new coefficient, we multiplied the coefficient by the exponent, so we got 6. And to figure out the new exponent, we subtracted 1 from the old exponent, so 3 minus 1 gave us 2. And we do that again, and we get minus 4. And the 1, because it's just a constant number, goes away. So our derivative is 6x squared minus 4. Now our third step is to use that to find the slope. So we have to plug in x into the derivative to find the slope. Or gradient, whichever one you prefer to call it. Okay, so let's do that. Slope is 6x squared minus 4, so slope is 6. We know that x is 3, still 3, minus 4, and that gives us 50. It gives us 50. I'm actually surprised by the large numbers that I have here, but that's totally okay. We are good to continue. So now we have a point and we have a slope, and like magic, this just turned into a coordinate geometry question. So let's move this up here so we can still see the question. All right, so let's write down what we have. We have, or just circle it, we have the slope, and we have our y coordinate, and we have our x coordinate. So it's a point, and a slope. So because we're looking for the equation of a line, we can now plug into, let's actually write down the fact that this is a step that we're about to do. It is finally our step 4. We're going to plug x, y, and m, remember m is slope of a line, into y equals mx plus b to find the y-intercept, to find b. So let's do it. We have, let's write that down here, we have y equals mx plus b. And remember our y we found to be 43. 43 equals m, which we found our slope to be 50, times 3 plus b. So 43 is 150 plus b, which means that b is equal to negative 107. Which, when you look at that original line that we drew, it was so very steep that that does make sense that it would be crossing our y-axis very, 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 very low. So it looks like it would be crossing our y-axis at negative 107. Now we have everything we need, so we can finish it with step 5, or the end, which is, let's see, do I have space for this? I'll just write it down here. Step 5, write the equation. That's it. Let's see. Remember, it's the equation of a line. So it's going to be y equals mx plus b. And so we have y as y, m as the slope, which is 50, x plus b, which we found to be minus or negative 107. And that's the equation of the line, of the tangent.